James, thank you for being here.
Yeah, glad to be here, thanks.
Can you tell me a bit about your academic journey?
Well, so basically I'm interested in doing various ICT communication, information and communication technologies for addressing climate change.
Okay.
I just read in the paper today where James Hansen said that we are going to blow past the 1.5 degrees Celsius limit. So there's no way we can release that, and the consequences are getting worse and worse, and now it's like 2 degrees, but we're not going to escape the consequences. So basically I have a long history of working in Silicon Valley in various ICT fields like networking and cloud computing, and about 4 years ago I pivoted to using these for addressing climate change. Specifically I was interested in building decarbonization and renewable energy.
Yeah. And you wrote a paper as well?
Yes, right. The paper is about some work that I did last year. There's a building energy monitoring and control system called Voltron, which is from the Pacific Northwest Labs in Washington. And it's open source. And it's delivered as kind of a monolithic Python blob. So basically you install this on a computer, and then everything is installed in one place, and there's very little modern containerized and microservices architecture, even though internally within the blob it's architected very well to be separated out into microservices. So what I did is...
Why would you want that?
Because what you'd like to be able to do is take let's suppose that I'm running a service. I'd like to be able to take a container and deliver it to different customers with only only modifying some configuration, and not have to reinstall the whole thing. So you could basically install the container from remotely over the air, or and if the customer had the same devices in their building automation network, you could use the same container for every customer. You didn't have to go through a complicated, and all you had to do was set up the configuration. You didn't have to rebuild the software. So
makes sense.
Yeah, so this makes it more secure, because once you have the one container secured and locked down, then you can use it. And it's kind of like build once and deploy everywhere. That's the idea.
Okay, and how does that help the environment?
Right. So basically, one of the ways to reduce carbon in the at the high level, buildings generate about 30% of the carbon in the U.S., somewhere around that, and they use 70% of the, they use 70% of the electricity. So this is what's known the operational carbon emissions, which is basically scope 1 and 2. So what you want to be able to do is somehow reduce that, and there are certain times when the grid becomes extremely, the emissions intensity becomes very high. Like for example, in California, we have times in the summer between 4 and 9 when everybody in the Central Valley turns on the air conditioner because it's 110 degrees, and they have to start off a gas peaker plant. So if you can set it up so that you can pre-cool those houses down below, say like 72 degrees during the afternoon when there's a lot of solar on the grid, then in the evening they can just sort of gradually heat up. You can turn the air conditioner off, and they can sort of gradually heat up. So that's the basic idea. This is something called flexible load, and there's a lab in Berkeley that's working on this, a Berkeley Flex Lab. And
does it work?
It does, yes, right. I actually use this in my own house. Wow. So basically I have a heat pump, and I basically heat the house up in the winter to 66 degrees in the afternoon, and then let it go down to 64 at night from the 4 to 9 period. Although there's not as much demand for electricity in the winter as there is in summer, and I don't use air conditioning in the summer at all, because I live in this area and you don't need it really. Still, the utility tariff is more from the 4 to 9 period than it is at other times, and so that way I can get the benefit of reducing my electricity consumption in a smaller bill.
Good for the environment.
Right, exactly.
Okay.
Grid emergency. Grid emergency is when the California wholesale operator, CAISO, says, we're not going to have enough power tomorrow from 4 to 9 p.m., so we're going to schedule rolling blackouts. right?
Okay, yeah.
So the grid has to be, it's a consummate market. You have to basically have the supply and demand has to be balanced at all times. If you have too much supply, you have to curtail, which happens with solar.
Yep.
Sometimes in the summer, actually in the spring when there's more solar on the grid than people using it. And if you have too much demand, then you have to basically have a rolling blackout.
Yep.
So the grid operators want to avoid the rolling blackouts. And so what virtual power plants do is they help them to balance the grid that way, because they operate during the period when there's too much demand and not enough supply.
Yep.
And they can then provide more supply either through generation or by the reduction of demand through flexible load. So that's the idea.
Okay, so well, I'm curious to hear more about your work later on.
Yeah, okay.
How's the conference been so far?
It's been okay. The food was great.
How's the talk been so far?
I only attended the security session, and then I came in here, and that was it was about forensics and digital forensics. And I'm going to go back when I'm done here until my session is ready. Security is the other thing I'm sort of interested in. So
we won't keep you any longer. Okay. Enjoy the rest of the conference, and thank you so much.
Yep, right.